Okay, I'm having to re-record this intro because like the video like got corrupted, which is really annoying. But welcome to the Unit 2 study guide, like practice video. A few things I wanted to reiterate to you. Number one, this is tinyurl/calclub, is like tinyurl to my calculus Google Drive where you get all the resources, blank versions of this, everything completed, no toolkits, etc. The other thing is that like you got to finish all the delta by 9:30 a.m. on Monday. Like they're going to be closed after that. They will not be accessible. So got to be done by 9:30 a.m. on Monday. Come to office hours, obviously Tuesday, Thursday, and then morning office hours on the Monday. I did this in a previous video. I kind of went through this. I'll walk you through it. This is just so you know, like not necessarily absolutely everything you need to know. It's just the majority, and maybe there are a couple things on here that aren't on here that you might need to know. But like this is the meat of it. Okay. So first is the two possible formal definitions of the derivative. One with as h goes to 0, and the one as x goes to a. F of x minus f a over x minus a. Just be familiar with them. I'm not going to ask you to solve a derivative from scratch with it, but I'll ask you to identify it. You have the exponent rules. X to the power of negative a is 1 over x to the a, and then the b root of x to the a is x to the a over b. Really important that you know both of these. Then you need to know the basic power rule, obviously. Super, super important that you're familiar with that and like very fluent in it. That constants are 0, and then sine and cosine. Okay. Equation of the tangent line. You have to know this formula. So important. When you see this question, know to write that formula and know to find the values. And then the rest of this, at least from here to here, is basically like stuff from that sheet I gave you, like the kind of derivative guide. It's like, okay, when f is increasing, derivative is positive. When it's decreasing, derivative is negative. Critical points are when the derivative equals 0. Relative max is when we change from positive to negative. Relative min is when the derivative changes from negative to positive. When the second derivative is 0, you may have an inflection point. You know for sure if it's changing from positive or negative. The second derivative is changing from positive to negative. When the second derivative is positive, it's concave up, and the derivative is increasing. When the second derivative is negative, it's concave down, and the derivative is decreasing. So like I would probably make flashcards for these, honestly. Everything from here to here, this region, flashcards. Like you really should know these very, very fluently, that these are the same thing. So like I'd have on one side f increasing and on the other side this. Okay, that would be these. The equal signs are like each flashcard. And lastly, differentiability, which we would have done on Tuesday, is just saying that it has to be continuous, like the function needs to be continuous at that point, but also the limits have to be continuous at that point. So anyway, on with multiple choice. There we go. Okay. Let f be a differentiable function with selected values in the table above. What is the average rate of change of f over the closed interval of 0 to 10? Alright, so average rate of change. Didn't actually put that in the notes, but you should know this. Average rate of change is f of b minus f of a over b minus a. This should be in the notes. You should know this. So from 0 to 10, so 10 is your b, 0 is your a. So the average rate of change is f of 10 minus f of 0 over 10 minus 0. Okay, so what's f of 10? F of 10 is this f of 10 right here, negative 20. So it's negative 20 minus f of 0 is 5 over 10. Negative 20 minus 5 is negative 25 over 10, which is the same as divide top and bottom by 2, negative 5 over 2, which is b. So number one should be b. This one, okay. This is, let me make that very clear. This is the derivative right here. That says asking for the derivative. This is a callback to the limit definition. So again, when you look at the limit definition, it's saying like, you write it out like this, but it's really just saying we want the derivative of this. So as you can see in all these, they've done it so it is that second term here, but it's all written incorrectly or different ways on the left hand side. That's the only thing that's different. Like they all have the minus each one. They all have this written correctly. Remember when you do f of x plus h, that's going to be the left side, right? You're literally putting x plus h in for x. So it's going to become 3x plus h squared plus 2x plus h. And the only one that does that correctly is C. The problem with B and D is that it is the limit as h goes to 0. That's the limit of efficiency. H goes to 0. It's the limit as h goes to 0, not x. So when you're seeing those h's in there, that's the indication. That immediately eliminated those two. And then you just know that, oh, x plus h is going in for x. That's 2. 3. Which is the following is an equation of the tangent line to the graph y equals cosine x at x equals 1/2. Okay, equation of the tangent line. What did I say when you see that? So some of you may have been freaked out when you saw this question, like what? Like cosine? Like what am I doing here? But you don't, like it's always the same process. Y minus y1 equals mx minus x1. Okay? y1, I don't know yet. x1, I know. x1 is pi over 2. Okay, y1 equals cosine of pi over 2. Cosine pi over 2. Cosine pi over 2 is 0. Okay. I will give you on the test like a little like chart of the key sine and cosine values. So like you don't necessarily need to memorize that, but you should know that cosine pi over 2 is 0. Like, you should know that. Okay, so that's 0. And then the slope m I get by taking the derivative. So like cosine is my function, y equals cosine x. So my derivative of that, remember the derivative of cosine is negative sine x. And then I'm going to plug in pi over 2. So I have negative sine pi over 2 is my derivative at pi over 2. So negative sine pi over 2. So sine pi over 2 is 1. So negative 1. That's equal to negative 1. So my m is negative 1. So let's plug it in. We're going to get y equals, because it's y minus 0, so that just becomes y equals. Let me write that just so it's clear. Y minus 0 equals negative 1 times x minus pi over 2. Let's simplify that. Y minus 0 is just y equals negative x, negative 1 times negative pi over 2 plus pi over 2. That is right here. I'm sure as you're doing this, you understand the x1, y1, and m, and the main thing confusing you is probably the sine and cosine. Just bear in mind that, yeah, I will give you the table of values for pi over 2, pi over 3, etc. So you don't need to worry about memorizing that. That's the only thing I'll give you, okay? All right, moving on, number 4. If f of x equals 4 over x plus 5x minus 1, then f prime of 2 equals the derivative at 2 equals what? So you need to find the derivative. Okay, so 4 over x is, let me alter that up here, so that's 40x negative 1 to the power of negative 1. 5x is 5x, negative 1 minus 1 is minus 1, so that doesn't change. Power rule this. Negative 1 times the 4 is negative 4x to the power of negative 2. Plus 5. Okay, let's fix this. That's the same as negative 4 over x squared plus 5. Then let's plug in the 2. That's negative 4 over 2 squared, right? Plus 5. That is negative 4 over 4 plus 5. That's negative 1 plus 5, which equals 4. Answer is 4. A. 5. This one looks really tough. Like it kind of looks overwhelming because you're like haven't not seen something like this before, but it's actually not as hard as you think. The graphs of linear functions f and g are shown above. If h of x equals f of x plus g of x, then what is the derivative of h of x equal? Well, the derivative of h of x is just equal to the derivative of f of x plus the derivative of g of x. So remember, derivative equals slope. Okay, Now, since these are lines, the slope is the same at every point, and you can see rise over run right here. The derivative of f of x is 1, because the rise over is 1 over 1. The slope is 1. And the derivative of g of x is, let's see here, I need 2 points, here, here, here to here. Yeah, that's negative 2 over 3. So the derivative of g of x equals negative 2 over 3. So let's plug it in. H prime of x equals derivative of f of x is 1 plus derivative of g of x, that's minus 2/3. 1 minus 2/3 equals 1/3. So for this one, derivative means slope. So if you see a graph and it's asking for derivative of something, you're going to need to do the rise over run of the slope of it, and that's where in this case you find the derivative of the slope of each individually and then add them together down below, and that's how you got 1/3. Okay, moving on to number 6. The graph of f prime, let me get really clear, this is f prime, this is f prime. The derivative of f is shown above for negative 2 to 5. On what intervals is f increasing? So this is where the notes come in handy, which you can't use on the test, but you can refer to now. You need to know when f is increasing, f is increasing, the derivative is positive. I'm looking at the derivative. So where's the derivative positive here? That's the question. So like, where is derivative positive? Derivative positive means f increasing, right? So where's positive? Here and here, right? So what are the intervals? Negative 2 to 3. Negative 2 to 3. And like, I know it hits 0 right here, but that's okay. We still count it as long as it doesn't cross over to the side, it still counts as increasing in that interval. Okay. And that's not even that's not relevant based on the options anyway. 7. The figure above shows the graph of a polynomial function. Let me make sure that's centered. The figures above shows the graph of the polynomial function f, for which values of x is it true that the second derivative is less than the first derivative is less than the value. Okay, so this is just a reminder, like this is concavity, this is slope, and this is like the value. So these always are kind of the same thing. Like they're not like specific numbers, they're positive or negative. And if it's always like positive, 0, and negative. So if your biggest value is positive, like if this is my biggest value, it should be positive. If this is my middle value, it should be 0. And this is my smallest value, it needs to be negative. So I'm looking for somewhere where the value of the function is positive and the slope is 0 and it's concave down. So I want concave down. I want horizontal tangent line. And I want like a positive value, positive f. Okay, so on my options, like immediately I know it's B. Like I know it's B because it's the only one with a positive function, positive value function, like a positive y value. And I'll check it out to make sure it's true. Notice that we have a tangent line of 0, and notice how it's concave down here because it's got the n. I'm going to take a second just to remind you this. Concave down, I remember that from the n because it always looks like an n. And like you can see, like this is clearly like an n that this point is on. And then concave up, I remember this from the u because it always looks like a u. That's concave down, that's concave up. If it ever looks like a u, it's concave up. If it looks like an n, it's concave down. So the answer is B. B. 8. If g is the function given by g of x equals 1/3 x to the third plus 3/2 x squared minus 70x plus 5, on which of the following intervals is g decreasing? So again, decreasing means that the derivative needs to be negative. And the way that you test this when it's an algebra function is that you got to take the derivative. So we need to find the derivative of g prime of x, which is going to be 3 times a third is just x squared plus 3x minus 70. this factors into x plus 10. No. Yep. Yeah, x plus 10, x minus 7. Two numbers that multiply to get negative 70, add to get 3. And my solutions would then be x equals negative 10 and x equals 7. So we can draw out the number line. You don't have to do all this. I'll show you a trick in a second that gets you through these questions. Negative 10 and 7. And then you would test a point in between if we want to be really thorough. You can, so let's see, an 8. An 8 goes in. When I put an 8 here, it's positive, positive, so that's positive. When I plug a 6 in, it's negative, positive, so it's negative. When I plug a negative 11 in, it's going to be negative, negative, which is positive. So where is it decreasing? It's decreasing from negative 10 to 7. I can see it clearly. If you get stuck on this, or like I don't know, like you're in a situation where you can't factor it. Let's say like you get like, you're like, okay, you got to this point, but you couldn't do this for whatever reason. One of the tricks you can do is to like try the values from these intervals, and if you plug in like, I don't know, like an 8 into this, you would see that it was positive, and then you could eliminate that. Does that make sense? Like, rather than doing the full thing, if you could, for some reason you were not able to factor it, you can test points in these intervals, and if it's positive in the derivative, you know it's not true here. All right, 9. The graph of f prime, the derivative of f, is shown in the figure above. On what intervals is the graph of f concave up? So, so the derivative tells you two things. This is back to the notes. Concavity. Where was this? Yes. If the second derivative is positive, then the function is concave up and the derivative is increasing. If it's negative, it's concave down and the derivative is decreasing. I'm looking at the derivative and I'm trying to figure out concavity. So in this case, I'm looking at increasing or decreasing. If I was looking at whether the function was increasing or decreasing, I would be looking at positive or negative. But since I'm looking at concavity of f, I'm looking at where this is increasing or decreasing. So where this is increasing, it's concave up. So where is it increasing? Well, it's increasing from A to B, and it's also increasing from D to E. So my answer would be D. A to B and D to E. It would be concave down in these intervals. In this interval here, rather, from B to D. That would be concave down. The whole thing, it's increasing. The function is increasing on the whole thing because it's all positive. But it's concave up from A to B and D to E because that's where the derivative is increasing. Okay. 10. We got 3 graphs. One is a function, one's a derivative, and one's a second derivative, and which one is which? That's the question. So a nice way to help you with this one is when the derivative crosses the x-axis, that indicates a maxima or a minima on the original function. So if I see that it's got a max or a min, then I would want to see an associated 0 on another point. So like an example of this would be looking at this one. It's crossing here. Is there another function with like a maxima or minima kind of roughly around here? Well, yeah, if you look here, this one, these 2 points kind of match. This 0 matches that. And likewise, if you look over here, this has got a minima here, and that kind of hits the x-axis here. And this, you can kind of see, has a kind of a maxima going on over here, and it's got a point right here. So it's looking like this is the second derivative, this is the first derivative, and this is the original. So here, the graph of f is 1. the first derivative is 2 and the second derivative is 3. A. Yeah, that's how I do it. I mean, you can always, what I was doing there was I was like kind of going through in my head as well, just to double check. When this is negative, this should be decreasing, which it is. When it's positive, this should be increasing, which it is. When this is negative, this should be decreasing, which it is. When it's positive, it should be increasing, which it is. So it is A. 11. The graph of f, the derivative of f, is shown above. The function f has a local maximum at x equals what value? So this is, again, I'll refer back to the notes. You have a maxima, local maxima, when the derivative changes from positive to negative. So where this is changing from positive to negative, I'm going to have a maxima. So right here, you can see it's changing from positive to negative. That's my maxima. This one right here would be the minima because it's going from negative to positive. This one's going positive to negative, so that would be the maxima. Okay. So that would be at 1. C. All right, nearly over with the multiple choice. 12. The graph of the function f is shown above of the following intervals on which is f continuous but not differentiable. So this is from our latest lesson on Tuesday. It's not differentiable here and here. It's not differentiable and not continuous. So I'm going to label that just so you know. This is not differentiable and not continuous. Here, you notice this is continuous, but not differentiable. It's called, that's the cusp, differentiable cusp. So whenever you have a cusp or a kink in the function, that is not going to be a differentiable point. So that would be at of the following intervals on which is f continuous but not differentiable. So 0, 1 was differentiable. 1 to 2, it's not differentiable there, but it's not continuous. 2 to 3, that's the 1. Because on this interval, that's where it contains the cusp. It's not differentiable at that point, but it is continuous on 2 to 3. And 3 to 4 is not differentiable, but it's not continuous there. 13. Let f be the function defined above where c and d are constants. If f is differentiable at x equals 2, what is the value of c plus d? I'd say this is probably one of the tougher ones I gave you on the multiple choice. To be differentiable, that means that both the function and the derivative are continuous at that point. I have a limit at that point. So we can say cx plus d needs to equal x squared minus cx, and let's take the derivative of this. I'm going to write the derivatives out here. That's going to be c, sorry, it's going to be c, and then the d will be 0 over, and then down here it'll be 2x minus c. So also c equals 2x minus c. And then we're going to plug in the 2's into these. We're going to have 2c plus d equals 4 minus 2c. And then over here we're going to have c equals 4 minus c. So for this one I can solve this fairly easy. I'm going to add c. It's going to be 2c equals 4 divided by 2 divided by 2. c equals 2. Then I can plug c into this one to solve for d. So it'll be 2 times 2. So I'm taking this and it's going in here and here. 2 times 2 plus d equals 4 minus 2 times 2. So that's 4 plus d equals 4 minus 4. 4 plus d equals 0. Minus 4 minus 4. D equals negative 4. So negative 4 plus 2. That's right, what I'm doing. C plus d. 2, which is just like 2 plus negative 4, which is just 2 minus 4. So you can see that what I'm doing. Hopefully I wasn't covering that there. 2 minus 4 is negative 2. So it's B. Alright, that's multiple choice. Now time for the FRQs. Okay, guys. FRQ. Number 1. Given f of x equals x squared plus 15x plus 14, find the derivative f prime of x. Do some power rule here. So derivative is just going to, let me rewrite this. Derivative is just going to be 2x plus 15. Easy, easy, peasy question. The derivative at negative 7, that just means plug in negative 7 into that. So 2 negative 7 plus 15. Let me like set a good example here. Always use like really good notation. Like always show me what you're doing. Like always show me like this is what I'm doing. This is what I'm finding so that I know. So negative 14 plus 15 is 1. Find the equation to the tangent line to f of x when x equals negative 4. So that equation of tangent line, you should be in the habit, as I have said, of writing the all-important equation when you see this. Y minus y1 equals mx minus x1. Points for just doing that, I'd say, for sure. Some points just for writing that. And then you need to identify your x1, y1, and m. x1 is given to us, it's negative 4. y1 we're going to get by plugging the negative 4 into our equation. So we need to find f of negative 4, which is going to be negative 4 squared plus 15 times negative 4 plus 14. I know the handwriting there is not the best. That's 16. 15 times 4 is negative, so negative 4 is negative 60. 16 minus 60 plus 14. 16 and 14 is 30. 30 minus 60 is negative 30. Yeah. So right here, y1 is negative 30. And then my m, so that's the derivative at negative 4, which I already found. The derivative was 2x up here, 2x plus 15. So I'm just doing 2 times negative 4 plus 15, that's negative 8 plus 15, that's 7, yep, 7, so my m is 7. So you plug in the x value into the original, you plug it into the derivative to get your m, your slope, and once you have all of that, you're just subbing them in. So it's going to be y, in this case, my y minus, I'll write the whole thing out, negative 30 equals 7x minus negative 4. When this simplifies, it'll be y plus 30 equals 7x plus 4. And if you wanted to put it like in the final form, yeah, sure, you can do that. This is fine for me. This answer here is fine. If you wanted to put it into the full form, that would be y plus 30 equals 7x plus 28 minus the 30, y equals 7x minus 2. So either of those is fine. No bonus points for writing like that. If you get it like that, you're good to go. Points labeled to the curve to give it slopes. Okay. So we got a bunch of slopes here, and we got to match them to the tangent lines of these. So right here we've got these different tangent lines. Go ahead and just draw them. I would recommend just drawing them here, here, and here. Ooh, here. So easy one is the C, because C, bottom of the relative minima, that is always 0. Slope's always 0. That's 0. Then I got 2 negative slopes, B and E, and I got 2 positive slopes, D and A. And notice I have 2 negative slopes and I have 2 positive slopes. Well, if you look at E is a little bit shallow of a negative slope, and B is a little bit steep of a negative slope. That indicates that B must be negative 3 and E must be negative 1/2, because E is shallower than B. So E must be this one and B must be this one. Same thing with A and D. Like D shallower, A steeper, so A must be 3 and D must be 1. Okay, that's 1 and 2. Okay, we got some power rule. Good old power rule. 3x squared, guys. Write it out nicely like this. 3x squared. Negative 5 becomes 0. Easy. This one, easy. 5 times 4, 20x to the 4th plus 4x. Pi, 0, because it's a constant. Okay. Again, 5 times 4, 20. 5 minus 1, 4. 2 times 2, 4. 2 minus 1, 1. Okay. This one, 4 times a 4th is just x to the 3rd. 4 minus 1 is 3, right? that's just x, and 1 over e, number, it's a number, same thing as this, constant, 0. So that's your answer here. Just the good notation. Put the marking in. With this one, d, you gotta multiply it before you take the derivative. So we got 5x to the 6 minus x, and then 3x squared minus 2. 5 times 3 is 15. X to the 8th, negative x times 3x squared is going to be negative 3x to the 3rd. Negative x times negative 2 is 2x. 5x to the 6 times negative 2 is, I'm covering this, aren't I? 5x to the 6 times negative 2 is negative 10x to the 6th. Combine these all together, I get 15x to the 8th minus 10x to the 6th minus 3x to the 3rd plus 2x. Now I can take the derivative. So this one just has the added step of like multiply before you take the derivative. 8 times 15, so 8 times 10 is 80, 8 times 5 is 40, so that's 120. 120x to the 7th minus 6 times 10 is 60x to the 5th minus 9x squared plus 2. Okay, easy. Let's do these. So like these are pretty straightforward, right? These are pretty straightforward. This one you have to multiply before you take the derivative. These two I'd say are the more challenging ones. I might even need scratch paper for these. For right now I'm just going to do e right here. So I'm going to first rewrite it in terms of exponents. So we have x to the 3/5 plus x to the 7/3. So power rule this. It's going to be 3/5 x to the 3/5 minus 1. So remember, 3/5 minus 1 is like 3/5 minus 5/5, which is negative 2/5. Like that. And then this one plus, it's going to be 7/3 comes out front, x to the 7/3 minus 1. So 7/3 minus 3/3 is 4/3. So you get that. This would be the derivative. I would accept this answer. I'm gonna go all the way just for reference. This is the same as 7. These two like go on top, 7 times x to the 4/3, and that's gonna be the 4th root of x to the 3rd. And then this one will be, that'll move down because it's negative. It's gotta go down and be positive. 5 times the 5th root of x squared. So these two are the final answer for E. Okay. Let me get some scratch paper to do F. Okay, I'm back. Here we go. F. So it's d dx, just means derivative, right? That's just another word for derivative, another way of saying derivative of x to the 5th. All right. So for this one, you could definitely easily see this on multiple choice or something. This is the same as x to the negative 5th, and then you can do power rule. So it's negative 5x to the negative 6, which when you put it back in the denominator is negative 5 over x to the 6th. So that's that one. Not too bad. Bring it up top, right? That's what I did there. Make it negative. Apply the power rule. Bring the negative 5 down. Negative 6. Negative 5 over x to the 6. And I put it back down in the denominator. And then F. So F, I really want you to pay attention to F, because this, I can see so many students getting this wrong. Because you've done these problems, but every time you've done these problems, the f of x has been in parentheses, and I'll show you what I'm talking about. So this one, you don't actually analyze this, like you don't take the limit of it. This just means, remember, the derivative of f of x. So like, let me get that note sheet. When you see this, you see this form, you should immediately be thinking in your head, we're taking the derivative of something. And in this case, it's the f of x, which is right here. So I'm taking the derivative of this, like, f of x right here, if that makes sense. Can zoom in on this so it's like more clear. Like this is f of x. The thing is, it's minus f of x, which means, like, notice how it's like all these negatives are here. If it's not in parentheses, you have to factor out the negative. I'll show you what I mean. So I'm factoring out a minus from all of these, so it's minus 3x to the third plus 2x squared minus 5x. Do you see what I did there? Because like, this is normally how you're used to seeing it being written in your, like in delta math. It would have been in parentheses, but since the negative was distributed, this is really your f of x. Like this is f of x, what's in here, not this. So negative 3x to the third minus 2x squared plus 5x is not f of x. That's had the negative distributed to everything. You have to factor out that negative, and then you have your f of x. So f of x equals 3x to the third plus 2x squared minus 5x, not this. And then take the derivative. So 9x squared plus 4x minus 5. Easy. Okay, good. Let's sketch some derivatives. Okay, these are not so bad. This one here, you see it's just a linear relationship going down. Remember, derivative is slope. And so the slope of this is always some negative number. So when I draw this derivative, it's just going to be some negative number going from left to right. It could be anything like that. It's constant because this slope is always the same. The slope's never changing, so it's always the same slope here. Hypothetically, like, just imagine like this was y equals negative 2x, right? And this is negative 2. Like the slope is always negative 2. That's what this is showing. This one, slightly harder. Whenever you get a derivative that you have to draw, like always mark that that maximum and know that your derivative has to hit 0 at that point, and then build it from there. So notice how we're increasing here, meaning that my derivative has to be positive, right? You can also see like, okay, it's super steep right here, getting shallower. So that's why I'm coming from above. And then as we go down the other side, it's like a little bit shallow, and then it's like really steep, and then it's steeper. So it could look like any version of this. Honestly, as long as it's crossing the x-axis at that relative maxima, that's like the main thing I would be looking for. This one never crosses, it's always increasing. It's concave up. It never turns down. So the derivative is also the same. It's also always going to be positive and increasing. So it could look like that. I would also accept like a line, anything like that. But it's always increasing and always positive. Number 5, last page. This went by too quick, guys. Use the graph of the continuous function f of x to answer the following on the interval -3, 8. Estimations. Okay. Let me like highlight this a little bit so you can sort of see it better. I'm going to do this when I make copies. Okay, up there like that, and down, back up. Okay, where is f of x increasing? So this just means going up. Where's it going up? Well, it's going up here to here. It's going up here to here, and then it's going up here to here. So where's it increasing? I'd say like -3 to, I don't know, we'll call that like -1.8 and 0. That looks like definitely like a 0 to, that's like almost 4 but not quite. If you put 4, I wouldn't blame you for doing that. 3.8 we'll call it. And then from, I don't know, like 7.5 to 8 kind of looks like. If you're like a little bit off from my intervals, that's okay. I don't mind. Where's the derivative positive? Guys, these are the exact same question. Where is it increasing? Where's the first derivative positive? Same thing. So it's just the same answer. I'm not going to rewrite it. It's the same thing. Same answer. Where's the first derivative negative? That means decreasing. So you got to know this means decreasing. Decreasing f, right? This means f increasing. So decreasing, where's it decreasing? Here and here. So we're going to say, I'm going to pick up where I left. I'm going to be consistent, right? So if I stopped at -1.8, I need to pick back up at -1.8, -1.8 to 0. And then from 3.8 to 7.5. where is my derivative 0? So these are the horizontal tangent lines right here, 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 here. So that's kind of at all these breakpoints. Negative 1.8, x equals negative 1.8. I'll just use commas, 0, 3.8, and 7.5. Where is the second derivative 0? So these are inflection points. Okay, yeah, these are relative extrema. These are inflection points. So, and this, let's keep going. This is concave up. This is concave down. And we're not going to answer H. I'm going to make sure that's gone for the practice test I give you. So, inflection points, concave up, concave down. Where is this happening? Well, remember, concave up is like the U. So like think of the U, right? So where do we have a U here? Well, I've got a U kind of like here to here. It's kind of a U going on, and I've got a U here to here, and then I have concave down that's the N, right? So where do I have N's going on? I have an N coming from here to here, and then from here to here, right? So let's label that. Again, estimation's okay. Like it doesn't need to be perfect, but the N, we're gonna say starts from -3, and we're gonna say that stops roughly around -1, right? Because that's kind of like the in between the N and the U. So we're gonna go -3 to -1, and then it's gonna be concave up from that -1. I'd say roughly to the 2. So from -1 to the 2, it's gonna be concave up. And then we're going to go concave down again from 2 to roughly 3, 6 maybe. Or sorry, 5 or 6. It's kind of hard to tell. I'd take no, definitely not 5. I'd say the 6, for sure the 6. So we're going to go from 2 to 6 is concave down. 2 to 6 concave down. And then 6 to 8 would be concave up. That means that basically where these points traded off like are the inflection points. So it's going to be at -1 and at 2 and at 6. Those would be the inflection points every time it changes. So it changes at -1, changes at 2, changes at 6. All right, nearly there. First derivative is on the right. Answer the following: where is f of x increasing? Now you might be like, oh, Mr. Kelly, for sure. Also, I'm going to label this C. For sure, it's increasing here to here. Clearly, it's increasing here to here. I'm going to say from C to infinity, it's increasing. Wrong. Wrong, 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 wrong. Because you are looking at the derivative, guys. You're not looking at f of x. You're looking at the derivative. And if you're looking at the derivative, that means you need to follow the rules. When the derivative is positive, f increasing. Right? So where is it positive? It's positive here and here. So it's positive from -infinity to a and b to infinity. Where is it decreasing? So where's f of x decreasing? F of x is decreasing when it's negative, right? So it's negative down here. So it's going to be from a to b. Where is there a relative minimum? So relative minimums happen when our first derivative changes from negative to positive. So right here, see we're crossing from negative to positive. X equals b is a relative minimum because it's changing from negative to positive. Also, I could like easily say, justify your answer, right? So I'm just gonna practice that because f of x changes from negative to positive. I'm gonna do that for all of these because I could absolutely hint see myself saying prove it. Why? So f of x is decreasing here because derivative is negative, and f of x increasing because derivative, what about bc here, because, and then a bc, f of x is positive. Lastly, where is the second derivative greater than 0? That means that it's concave up in the function. And that means that that's the same as saying f of x increasing. Or the derivative is increasing. So where's the derivative increasing? That would be from c to infinity. That's where it's going up. Because the derivative is increasing. Again, that's in your notes. All right, we're on the home straight. I'm going to make a new video here. Okie dokie. Determine whether the function is differentiable, continuous, or both, or neither at the value where the rule for the function changes. Okay, so this is what we did on the last lesson. The limit as x approaches -5 from the left needs to equal the limit of x as x approaches -5 from the right, and the limit of the derivative as x approaches -5 needs to equal the limit of the derivative as x approaches -5 from the right. So basically, it's very similar to the unit 1 problem where it was like, oh, is this continuous at this point? Except with the added condition of like, you got to test the derivative as well. So you plug in -5 for both and set them equal to each other. We're going to have -5 squared plus 5 times -5 plus 4 equals -2 times -5 minus 6. So that's 25 minus 25 plus 4 equals 10 minus 6. That is true. Do you see that? 25 minus 25, those cancel. 10 minus 6 is 4, so it says 4 equals 4. So it is continuous. I can say continuous, right? Then for the differentiable, these need to match, so we're going to take the derivative of both of them. That's 2x plus 5 and -2. That's it. So we're going to set those equal to each other. 2x plus 5 equals -2. Plug in the -5. We're going to get -10 plus 5 equals -2. So it's -5 equals -2. These are not equal. So this means that it's continuous, but not differentiable. Okay. Last one. This is the big one. Got a function. Got to analyze it algebraically and graphically to determine where it's increasing, decreasing, concave up, concave down, and to identify where it has points of inflection at extrema. When I give you the practice test, I'm going to give you like a table, like I did with the practice quiz that you did on Tuesday, so you can like organize this a little bit better. Let's get started. When you're trying to figure out where it's increasing and decreasing, you need to take the first derivative. So we're going to do that first. First derivative is x squared plus 6x minus 16. We're going to set that equal to 0. And when you set it equal to 0, we're going to factor it. Two numbers that multiply to get -16, and they add to get 6. That's going to be x plus 8, x minus 2. So my solutions are x equals -8 and x equals 2. Draw the number line. I'm going to mark points at -8 and at 2, and I'm going to test them. Put in a 3, I'll get a positive, 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 increasing. Plug in a 0, it's between -8 and 2, right? I'm going to get negative and a positive. That means negative, so it's going down. And then number less, like a -10, -10 plus 8, -2. It's both double negative, positive, going up. Okay? So I can tell you right now, I can fill this in. We're increasing. I can fill in where we're decreasing. So we're increasing from -infinity to -8 and 2 to infinity, and we're decreasing from -8 to -2. And then we're going to have a relative max here at x equals -8 and a relative min here. Okay. So that's the first derivative side. Now we'll do the second derivative. So second derivative, again, take the derivative again of this. We're going to get 2x plus 6, set it equal to 0. 2x plus 6 equals 0. 2x equals negative 6, so it's minus 6 minus 6, divided by 2, divided by 2, x equals negative 3. There's only one solution. X equals negative 3, so we're going to put that right in the middle here. Test the point, test the point. We are going to put in a like 5 into this. 2x plus 6 is going to be positive, easy, and then like a negative 4. Easy is negative. So this is concave down, concave up. So we're concave down from, I'll write this here, concave down from negative infinity to negative 3, concave up, negative 3 to infinity, and then this would be an inflection point right here. One thing I also want to mention is like you may get a question like this. It's like, where is f of x increasing and concave up? And what I think is really helpful for that is almost to put all the points on one number line so you can really easily identify it. So I'm just gonna kind of copy over what I've got here. So if you're wondering where I got all this, I have negative 8. I'm gonna do like the first derivative on the top side, and I'm put the second derivative on the bottom side. I'll show you what I mean by that. So negative 8 there, and then negative 3 down here for my inflection, and then a 2 up here. And then I'm going to put this is increasing right here, this is decreasing right here, and then this is increasing right here. And then at the bottom, this is the concave up, this is the concave down. And from this, you can really easily like find whatever you want when it's on one number line. So if I want increasing and concave up, okay, increasing is here and here, but it also has to be concave up. That means it has to be like this region right here, right? Because that's increasing and where they're both true. So it would be 2 to infinity. Okay, that's where it's increasing concave up. If you wanted like decreasing and concave down, that would be this region right here, negative 8 to negative 3, because that's where they're both negative. So you're basically looking to match them up of where they're both true. All right, guys, that is the end of the practice test. Well done for making it this far in the video. You guys got this. I will see you in office hours.